Here's what you need to know about Tesla Bot Gen 3, and Elon Musk has confirmed that.
We look forward to unveiling Optimus V3, probably in Q1. I think it'll be ready for to show off, and that I think is going to be quite remarkable. It won't even seem like a robot. It'll seem like a person in a robot suit, which is kind of how we started off with Optimus. But it'll seem so real that you'll need to poke it, I think, to believe that it's actually a robot.
Okay, if the Tesla Bot version 2.5 we see now still requires teleoperated, then Optimus Gen 3 will be fully autonomous. Elon Musk has revealed at least 6 exciting features from this upcoming version, and we only have to wait just one more month to see them in action. The Tesla Bot has been a subject of intense discussion and anticipation since its first introduction. Musk's ambitious vision for this humanoid robot has already sparked curiosity, with many eager to see how far Tesla can push the boundaries of artificial intelligence and robotics. Unlike its predecessors, Optimus Gen 3 promises a significant leap forward in both functionality and autonomy. This robot is set to not only assist with household chores, but also revolutionize industries, healthcare, and more.
So we've made radical improvements to the design of Optimus while increasing the functionality, but making it actually possible to manufacture. I'd say Optimus 2 is almost impossible to manufacture, frankly.
The journey of the Tesla Bot began with the release of version 1, which was primarily a walking prototype, struggling to move in a natural manner and performing limited tasks. It was evident that the first version was more of a demonstration of the concept rather than a fully functional robot. By the time version 2 arrived, significant improvements were made with more refined movements and the ability to perform a wider range of tasks. However, the need for teleoperation was still very much a part of the experience. Therefore, Tesla Bot versions 2 and 2.5 still require teleoperation in some situations. But no one will buy a robot if it's only remotely controlled. And it was clear that Tesla was working toward a fully autonomous robot. And the road to that goal was long.
When you see Optimus 3, it will seem as though that there's someone like a person in a robot outfit, which is how we started with Optimus.
Yeah. Optimus Gen 3 marks the real turning point. This is the version that Elon Musk has repeatedly stated will be fully autonomous. Tesla Bot Gen 3 will no longer require the operator to control its movements from a distance, a huge advancement that will enable it to interact with the world in a more natural and human-like way. The most significant advantage of this shift is the reduction in human intervention, which opens up the possibility of real-world applications without constant supervision. Whether it's in the home, factory, or even healthcare, Optimus Gen 3 is designed to handle tasks with a level of precision and reliability that previous versions simply couldn't match. The most significant and game-changing feature of Optimus Gen 3 is its full autonomy. As mentioned earlier, Tesla Bot Gen 2.5 still requires a human operator to control its actions through teleoperation. This means that while the robot can perform basic tasks, it still needs guidance from a person. However, Optimus Gen 3 will be completely different. It will be able to carry out tasks without the need for human input.
We're finalizing the design of Optimus version 3, and that really is going to be a very remarkable robot. It will have essentially the manual dexterity of a human, so meaning a very complex hand.
This includes performing complex actions like cooking, cleaning, and even interacting with people in a way that feels natural. The full autonomy of Optimus Gen 3 will make it a true assistant in every sense of the word, capable of handling day-to-day activities without supervision. Elon Musk has made it clear that the ultimate goal for Tesla is to have robots that can operate fully on their own, and Optimus Gen 3 is the next step in that direction. For instance, it could help elderly individuals with mobility challenges, handle household chores without any help, or work in dangerous environments where humans can't easily go. The fact that it doesn't require remote control opens up a wide range of possibilities for both domestic and industrial uses. One of the key features that will make Optimus Gen 3 truly revolutionary is its advanced AI. Unlike earlier versions, Optimus Gen 3 will have the ability to learn from its surroundings. Using Tesla's proprietary neural network, The robot will be able to adapt to new environments and tasks without being explicitly programmed for them. This means that Optimus Gen 3 will not only perform tasks it was originally trained to do, but will also improve over time as it learns from experience.
If Optimus can watch videos, YouTube videos or how-to videos or whatever, and based on that video, just like a human can, learn how to do that thing, then you really have task extensibility that is dramatic, because then it can learn anything very quickly.
For example, if Optimus is asked to cook a new dish, it can watch videos of the recipe being made, analyze the necessary steps, and then replicate the actions with high precision. This ability to learn from video tutorials and simulations is a huge step forward, as it allows Optimus Gen 3 to expand its skills and tackle tasks that weren't initially part of its programming. Over time, it will continue to learn, making it more capable and versatile in performing various tasks. Another critical improvement in Optimus Gen 3 is its enhanced mobility and dexterity. Previous versions of the Tesla bot struggled with walking in a natural manner and performing delicate tasks. While Tesla Bot Gen 2.5 made strides in these areas, it still wasn't as agile as it needed to be. Optimus Gen 3, however, is expected to have significantly better mobility. This includes walking at human-like speeds, running, and performing fine motor tasks such as opening doors or handling fragile objects. Tesla's engineers have spent countless hours refining the robot's ability to move like a human, which is no easy feat. Humans have complex movements, with the ability to adjust our posture, maintain balance, and perform intricate tasks that require high precision. Elon Musk has never hidden his ambitions. Everything is moving forward day by day, and Tesla Bot is no exception. Among the most notable improvements, movement speed stands out as clear proof of a technological leap. Tesla refuses to accept a timid, sluggish machine. But to create a humanoid robot that can move as naturally as a human, the company has had to pay the price in time, patience, and massive investment. The original target was just 5.5 miles per hour. Yet, in the latest demo video, Tesla Bot stunned the tech world by reaching 6.8 miles per hour, with a running gait that is almost indistinguishable from a human's, reportedly achieving up to 99% similarity. And it doesn't stop there. Tesla Bot's current walking speed has reached 4 to 4.5 miles per hour, a truly impressive figure. For humanoid robots, simply reaching around 2.5 miles per hour is already enough to be useful in home or factory environments. Anything slower turns the robot into more of a burden than a helper. Clearly, Optimus has far surpassed that minimum threshold. The reality is that slow speed kills competitiveness. Users, including all of us, expect a robot that is agile, responsive, and doesn't disrupt the pace of daily life. Speed isn't just a number on paper. It reflects the overall level of engineering, from joint efficiency and actuators to the sophisticated coordination of sensors and the battery's power delivery. Put today's Optimus next to the version unveiled in 2021, and the gap is almost unbelievable. Behind this transformation lie billions of dollars in investment and a long-term strategy, more than enough to demonstrate Elon Musk's and Tesla's serious commitment to bringing humanoid robots to the global market. And don't forget, what we're seeing now is only Optimus 2.5, not even the third generation yet. Optimus Gen 3 is expected to reach movement speeds of up to 5 miles per hour, a milestone that could redefine the standard for humanoid robots in the near future. Optimus Gen 3 is designed to mimic these human movements, making it more adaptable and reliable in real-world environments. The improvements to its dexterity will allow it to handle a variety of tasks, from cleaning windows to folding laundry, with ease and accuracy. Elon Musk has mentioned that Optimus Gen 3 will be capable of performing up to 4,000 different tasks. This could include everything from cleaning and cooking to more specialized roles in industries such as healthcare, manufacturing, and logistics. With its improved AI, it will be able to recognize and interact with its environment in a way that earlier models couldn't. For instance, Optimus Gen 3 will be able to assist with elderly care, providing support for mobility, monitoring health metrics, and helping with everyday activities. In industrial settings, it could perform repetitive tasks such as assembly line work, logistics, and inventory management. The wide range of tasks Optimus will be able to handle makes it a versatile tool that can be used across various industries and environments. With its advanced AI, mobility, and dexterity, Optimus Gen 3 will be able to perform tasks with greater efficiency than humans. Musk has claimed that Optimus Gen 3 will be 5 times more productive than a human worker. This is largely due to its ability to work 24/7 without tiring, needing breaks, or losing focus. Robots like Optimus Gen 3 can be deployed in workplaces where human labor is often limited by fatigue or the need for rest. In industrial settings, it could perform repetitive tasks such as assembly line work, logistics, and inventory management. The wide range of tasks Optimus will be able to handle makes it a versatile tool that can be used across various industries and environments. With its advanced AI, mobility, and dexterity, Optimus Gen 3 will be able to perform tasks with greater efficiency than humans. Musk has claimed that Optimus Gen 3 will be 5 times more productive than a human worker. This is largely due to its ability to work 24/7 without tiring, needing breaks, or losing focus. Robots like Optimus Gen 3 can be deployed in workplaces where human labor is often limited by fatigue or the need for rest. In factories, for example, Optimus could perform tasks like quality control, assembly, and material handling, all while working at a pace that human workers simply can't match. This increased productivity will not only reduce labor costs, but also boost overall output in industries that rely on repetitive manual tasks. Elon Musk sparked widespread public attention when he said that work will become optional and money will gradually lose its value, driven by the rapid advancement of AI and robotics. In the past, people feared that robots would replace human jobs. Now, Musk believes Optimus will usher in a future where humans may no longer need to work at all. It's an inspiring vision, but one that also raises profound questions about the future of labor in an automated world. Today, people still work to sustain their lives, earn income, and meet basic needs. But as AI and robotics evolve at an unprecedented pace, work itself may no longer be a necessity. Optimus Gen 3 stands as one of the clearest signs of that shift. Imagine no longer having to wake up early on a Sunday morning to clean the house, cook breakfast, or tackle endless chores. Optimus would handle it all for you. Household tasks could be completed without you lifting a finger. It may sound like science fiction, but this is precisely the future Tesla Bot Gen 3 is aiming for. A world where work becomes optional and people are free to enjoy life without working simply to survive. With the ability to perform more than 3,000 tasks, from cooking and cleaning to caring for the sick, Tesla Bot Gen 3 could be a game-changer for busy families. Now imagine its potential role in elderly care. Equipped to detect physiological signals, the robot could assist seniors with mobility, personal hygiene, and basic health monitoring. This capability is especially critical in modern societies, where aging populations are growing rapidly and healthcare systems are under increasing strain. Elon Musk has shared a vision for Tesla Bot that extends beyond household use and into the broader economy. As he has pointed out, the development of humanoid robots will not only replace certain jobs, but also create entirely new categories of work. With Optimus Gen 3 becoming a commercial product, Musk believes that this will lead to the creation of a new economy, one in which robots work alongside humans to perform jobs that are repetitive, dangerous, or labor-intensive.
Optimus will be an incredible surgeon, for example. And imagine if everyone had access to an incredible surgeon.
That's why Tesla Bot Gen 3 isn't just another household helper. It has the potential to take on medical roles, starting as a surgical assistant and possibly even performing surgery itself one day. It's still early, so nothing is guaranteed yet, but Elon Musk has made it clear that Optimus could eventually reach a level of precision beyond what human surgeons are capable of. One of the biggest reasons Optimus Gen 3 can keep working for up to 10 hours straight without needing a recharge is its upgraded battery system. According to Elon Musk, Tesla has moved to 4680 battery cells for Gen 3, allowing the robot to operate far longer without downtime. That's a huge leap from earlier versions, which only lasted a few hours before running out of power. On top of that, Optimus Gen 3 can recharge itself automatically. When the battery runs low, it simply heads back to its charging dock and plugs itself in. No human help needed. This makes it incredibly convenient and removes the hassle of managing power, which is a big win for both homes and businesses looking to automate tasks seamlessly. And unlike basic robots that only follow preset instructions, Optimus Gen 3 can actually learn from real-world experience, similar to how humans learn by watching and practicing. This is powered by Tesla's advanced AI, built on the same foundation as its full self-driving technology. That's what allows Optimus Gen 3 to recognize objects and interact with the real world with remarkable accuracy. Walk it into a kitchen, and it understands a knife is for cutting, a pan is for cooking, and plates are for serving food. Using 3D cameras and sensors, Optimus Gen 3 creates a full 3D map of its environment and plans its movements on its own. No human guidance required. With the stamina to perform repetitive tasks without ever getting tired, the Tesla bot could be rented out as a robotic worker, covering factory shifts, handling logistics, cleaning, caregiving, and more, while generating a steady stream of income. If priced below $20,000 and capable of earning around $2,000 per month, a Tesla bot could effectively pay for itself in under a year, then continue producing profit well beyond that point. Instead of eliminating jobs, robots like Optimus will create new opportunities for people in roles such as robot maintenance, programming, and training. This shift will allow humans to focus on higher-level tasks, such as problem-solving, creativity, and decision-making, while robots take care of the mundane and physically demanding tasks. Alright, this is something Elon Musk has mentioned before. If you own a restaurant, you could easily buy at least 4 Optimus robots for 4 different tasks. One robot to take orders and handle cashier duties, another to prepare food, a third to deliver meals to tables, and yet another to clean up. The upfront cost may seem high, but once robots replace multiple staff positions, the payback period would be very short. In just a few months, a restaurant could operate almost entirely on an automated robotic system, significantly reducing labor costs while increasing overall productivity. And this transformation wouldn't stop with the food service industry. Optimus could work in factories, warehouses, hospitals, retail stores, and even as in-home service robots through a rental model. This opens the door to an entirely new type of business, individuals buying robots and renting them out to generate passive income, similar to Tesla's upcoming robo-taxi model. Owners could list their robots on a shared platform, allowing Optimus to automatically take on tasks during idle time and generate a steady stream of income. Imagine thousands of robots deployed across factories, hospitals, restaurants, and even private homes. A single vulnerability in the system could allow a malicious actor to take control of an entire fleet, turning these machines into tools of disruption. Even a simple command like, "Fetch my medicine," could become dangerous if the robot's input data or decision-making process is manipulated. The release of Tesla Bot Gen 3 marks the beginning of a new era in robotics. With its full autonomy, advanced AI, mobility, and dexterity, Optimus Gen 3 is set to become a game-changer. Whether it's working in households, assisting the elderly, or performing tasks in factories, the potential applications for this robot are vast. While some may remain skeptical about the viability of humanoid robots, the rapid advancements in AI and robotics suggest that the future of work will be shaped by machines like Optimus. In just a month, we'll see Optimus Gen 3 make its debut, and it's clear that this robot will redefine what it means to be a human-like machine. Okay, so, would you trust a robot like Tesla Optimus to handle daily household tasks without supervision? Do you believe humanoid robot like Tesla Optimus will improve overall quality of life for most people? Drop a comment below. Sodium-ion batteries arrived late to the game, but they've quickly become far more powerful. Tesla has made moves toward adopting its most advanced sodium-ion battery technology, yet the Tesla Sodium-ion Battery 4.0. Elon Musk has said before that Tesla has studied many potential battery chemistries, but only a few were truly suitable for Tesla's needs, and sodium-ion is one of the rare exceptions. Early generations of sodium-ion batteries had energy densities far too low for electric vehicles, reaching only about 100 watt-hours per kilogram compared to the minimum requirement of 150 watt-hours per kilogram. But Elon Musk and Tesla didn't give up. They improved the materials and successfully developed a sodium-ion battery with an energy density almost equal to today's LFP cells, while cutting the charging time down to just 3 minutes. Oh my God, this is the first time a sodium-ion pack has ever achieved this, and it's something Elon can't really ignore. Right now, batteries are no longer the major bottleneck for Tesla, especially with the 4680 production lines ramping up at incredible speed. Of course, those packs are reserved for higher-end models like the Tesla Semi and Cybertruck. But with the upcoming $26,000 affordable Tesla launching next year, the company needs a stable, far cheaper battery than traditional LFP cells if it hopes to scale production. So, will the new sodium-ion battery 4.0 be the one Tesla uses? What makes this battery special enough to replace lithium, and why is it on track to become the cheapest EV battery in the world? It's not solid-state batteries or any other high-energy density chemistry that automakers are turning to as a backup plan. It's sodium-ion. With lithium prices rising, sodium-ion batteries are becoming the preferred alternative, especially for lowering production costs in affordable cars. We've seen many battery technologies emerge alongside lithium over the past few years. Among them, sodium-ion has shown the most promise, improving its energy density by 40% in just 2 years, a pace faster than any other battery technology in the world. And most importantly, sodium has one advantage no other chemistry can match: abundance. It's everywhere in nature, making it extremely cheap to source. Sodium-ion batteries are estimated to cost around $40 to $80 per kilowatt-hour, compared to the roughly $120 per kilowatt-hour of lithium-ion packs. In terms of availability alone, sodium is 500 to 1,000 times more abundant than lithium on Earth. On top of that, the extraction process is far less harmful to the environment and land compared to lithium mining. Although Elon Musk has stated that Tesla's new battery tech has eliminated lithium entirely, he also noted that the overall structure still closely resembles the lithium batteries Tesla used before. Simply put, the Tesla sodium-ion battery 4.0 still has a cathode, anode, separator, and liquid electrolyte. But instead of using lithium as the charge carrier, Tesla uses sodium. Additionally, both the cathode and anode can use aluminum, whereas lithium-ion batteries require copper for the anode, a significantly more expensive metal. Not stopping there, Elon Musk stated that the production cost of the new battery is even many times lower than that of the current 4680 cells. Instead of using expensive and scarce materials like nickel, cobalt, lithium, and copper, Tesla's fourth-generation sodium-ion batteries use a sodium-based cathode and rely on abundant, eco-friendly materials such as iron, aluminum, or manganese. In terms of test performance, Tesla's sodium-ion battery reaches 190 watt-hours per kilogram, higher than CATL's sodium-ion battery at 175 watt-hours per kilogram. So far, almost no sodium-ion battery has achieved such specs. CATL has said they will soon reach an energy density of 200 watt-hours per kilogram in the next generation of their sodium-ion batteries, but that still hasn't happened. Honestly, 190 watt-hours per kilogram is not a very high energy density. It's even significantly lower than Tesla's 4680 cells, but when compared to LFP batteries, which are widely used by many EV makers, it's clear that Tesla's sodium-ion batteries are not inferior. In fact, they're slightly better, even without taking production cost into account. With a 62 kilowatt-hour pack, Tesla's sodium-ion battery allows for a 300-mile range. Achieving a 300-mile range with a sodium-ion battery has never been an easy task. No sodium-ion battery has managed to do that before. According to Elon Musk, recent advances in material technology have significantly improved the performance of sodium-ion batteries, overcoming their inherent weakness in energy density. In terms of charging speed, sodium-ion batteries are very promising because they've demonstrated the ability to charge and discharge more than 20 times faster than lithium-ion batteries. With just a 3-minute charge, Tesla's sodium battery is said to deliver an additional 110 miles. Oh my God, this significantly compensates for the battery's not-so-impressive energy density. For any battery technology, the key factor that determines fast or slow charging is always the movement of ions between the electrodes during charging and discharging. In Tesla's fourth-generation sodium battery, sodium ions travel between the cathode and anode through the electrolyte. One reason this battery can charge and discharge so quickly is the favorable ionic conductivity of sodium ions in the electrolyte. Sodium ions carry a single positive charge, similar to lithium, but their larger ionic radius allows them to move relatively easily through certain electrolytes, especially those optimized for sodium-ion cells. In liquid electrolytes, Na+ can diffuse rapidly, enabling faster ion transport during both charging and discharging. This level of speed means it could potentially fully charge a Tesla Model Y in just 9 minutes. My goodness, that's practically comparable to filling up a gas-powered car. With sodium-ion batteries, you may get a vehicle with a shorter driving range, but you won't have to wait long before you can start your next trip. This balances out the experience compared to owning a long-range EV that requires nearly an hour to recharge. In Tesla's most recent efforts, the 4.0 sodium-ion battery has been shown to retain 80% of its capacity after 7,000 to 8,000 cycles. And we've also learned that sodium's durability could allow the battery to reach up to 80,000 cycles. But that's not even the most interesting part. Tesla's sodium-ion battery not only has a major cost advantage, but can also be considered one of the safest battery types for electric vehicles. Tesla conducted a series of extreme durability tests, from drilling directly into individual cells to cutting them in half, yet no signs of overheating appeared. This success largely comes from the sodium-based chemistry, which provides remarkable stability for this new battery type. According to Elon Musk, this battery line can operate across an extremely wide temperature range, from -40 degrees Celsius to over 70 degrees Celsius, essentially redefining thermal tolerance standards for batteries. At -40 degrees Celsius, Tesla sodium-ion battery still retains up to 90% of its usable capacity. Even when the battery is nearly empty, its performance barely drops in freezing environments. Compared to traditional lithium batteries, Tesla's sodium-ion batteries exhibit superior resistance to overheating, significantly reducing the risk of fire or explosion. Studies show that sodium's stable chemical structure makes the battery less prone to ignition and harder to explode in the event of a short circuit, increasing safety during technical malfunctions. In addition, sodium is a non-toxic material, which minimizes health risks if the battery breaks or becomes damaged. As a result, concerns about EV fires and thick smoke from lithium batteries are eased considerably. Another major advantage of sodium-ion batteries, and something we value highly, is their ability to maintain stable performance in cold environments. Many battery samples have demonstrated the ability to charge from 5% to 80% in just 15 minutes, even at -10 degrees Celsius. This makes sodium-ion batteries an ideal choice for regions with harsh winters, where severe performance drops in cold weather remain a major barrier that causes many users to hesitate before switching to electric vehicles. Okay, Elon Musk rarely talks in detail about battery prices, because even though the 4680 cells have been on the market for several years, their cost is still somewhat of a mystery. While Tesla hasn't disclosed the exact cost of each new battery cell, based on the average market price, if sodium-ion batteries are produced at scale, they could be 30% to 60% cheaper than LFP batteries, thanks largely to the abundant supply of sodium and the lower extraction and refining costs. As we mentioned earlier, sodium-ion batteries can also use aluminum as the positive current collector instead of copper, which is used in lithium-ion batteries, further reducing costs and supply chain risks. Replacing all the lithium in lithium-ion batteries with sodium can cut costs by as much as 30%. And what does that mean? A 30% reduction is a massive advantage. In many cases, just a few percentage points in price difference can determine the survival of an entire industry. If Tesla's sodium-ion battery 4.0 costs around $80 per kilowatt-hour compared to $120 per kilowatt-hour for LFP batteries, that would truly be a game-changer. Have you ever wondered why the industry even needs to turn to sodium-ion batteries when lithium-ion batteries have long been considered the gold standard? The answer is actually quite simple. Lithium-ion batteries can't fully solve the current challenges of electric vehicles, especially as automakers race to produce more affordable EV models. One of the key driving forces behind the rise of sodium-ion technology is that sodium is far more abundant and much cheaper to mine than lithium. This is becoming increasingly urgent as global lithium demand continues to rise and is projected to face severe shortages by 2026, directly impacting lithium-ion battery production. Although lithium naturally exists in various types of rock and even in brine, its reserves in the Earth's crust are far from limitless. Lithium extraction also consumes significant energy and resources. As demand for this valuable material keeps increasing while natural supply remains limited, lithium prices have surged dramatically, earning it the nickname "white gold" of the battery and electric vehicle era. For the electric vehicle industry in particular, sodium-ion batteries offer a substantial advantage, especially for Tesla and its ambition to introduce a $26,000 EV, a goal Elon Musk has long pushed for. Thanks to their low cost and independence from increasingly scarce lithium, adding a new battery chemistry like sodium-ion to the ecosystem brings long-term benefits. This becomes even more important when forecasts suggest lithium demand could increase by as much as 500 times in the future, making battery technology diversification not just a choice, but a survival strategy. As a key partner of Tesla, CATL is expected to soon introduce its second-generation sodium-ion battery. CATL has announced a target of reaching 200 watt-hours per kilogram for the next-generation version, currently in development, compared to the current generation's 175 watt-hours per kilogram. Furthermore, as we discussed earlier regarding sodium-ion technology, a former Tesla engineer has founded his own company dedicated to developing this type of battery. He is confident that his sodium-ion batteries will deliver a driving range of up to 300 miles. One of the most ambitious claims we've heard so far about sodium-ion batteries. So can Naxtra sodium batteries replace lithium batteries? In our opinion, the answer is no. Sodium batteries will not replace lithium batteries in the short term. Within the industry, it is widely believed that sodium-ion and lithium-ion batteries are complementary, not replacements for each other. Due to the lower energy density of sodium-ion batteries, they are more suitable for use in medium to low-speed electric vehicles and in large-scale energy storage systems. As industry investment increases, the technology matures, and the supply chain improves, cost-effective sodium-ion batteries are expected to become an important supplement to lithium-ion batteries, particularly in the field of stationary energy storage. They have a strong potential for development. Battery demand generally revolves around higher capacity, faster charging speeds, improved safety, and lower cost. From this perspective, aside from not yet being able to meet high-capacity needs, sodium-ion batteries have advantages in all other aspects. At this stage, sodium-ion battery products will primarily be used in applications requiring less than 150 watt-hours per kilogram, which could help alleviate the limited development of energy storage systems due to lithium resource shortages. There are no obvious bottlenecks for large-scale mass production of sodium-ion batteries, and they will rapidly gain market share with their unique characteristics in specific markets. Sodium-ion batteries are positioned as the most cost-effective and highly safe energy storage batteries. Once mass production is achieved, their performance is expected to reach that of lithium-ion batteries, but at the price of lead-acid batteries. The development of sodium-ion batteries is a process of self-innovation. Eventually, sodium-ion batteries will directly compete with lithium batteries for market share. Although CATL has outlined a clear timeline, the industrialization of sodium-ion batteries still needs to overcome challenges related to technical performance, supply chain development, large-scale manufacturing, and cost reduction. The inherent limitation of low energy density in sodium-ion batteries is widely acknowledged, and efforts to optimize this have never stopped. Increasing the energy density from 160 watt-hours per kilogram to 200 watt-hours per kilogram has become the key R&D goal for CATL's second-generation sodium-ion batteries. Naturally, improving energy density presents a time and effort-intensive challenge. Beyond energy density, current sodium-ion batteries can reach a cycle life of up to 5,000 cycles, though this is still significantly lower than that of commercial lithium iron phosphate batteries, which can last 8,000 to 10,000 cycles. To become the backbone of energy storage applications, sodium-ion batteries still need to go through further technical validation and improvement. In addition to Naxtra, CATL has also introduced the second generation of its Shengxing battery, which is expected to be installed in 67 vehicles this year from Chinese brands like Zeekr, NIO, and Avatar. This fast-charging battery can support a range of 800 kilometers and deliver 520 kilometers of range with just 5 minutes of charging, outperforming rival BYD from China. Its charging speed is truly impressive. CATL shared examples of vehicles charging at around 1,000 kilowatts, maintaining over 500 kilowatts even when the battery is more than 50% charged. CATL is also betting on the growth of battery swap systems, such as with its partner NIO, to help roll out its new battery technologies more widely. In summary, Naxtra sodium-ion batteries are emerging as a promising alternative to lithium-ion batteries in electric vehicles and energy storage applications. Over 18.32 million vehicles equipped with CATL batteries are currently in operation across more than 66 countries, demonstrating the reliability and effectiveness of the technology. Thanks to their high safety and the abundant availability of sodium-ion batteries reduce dependence on lithium resources, which is a key factor in solidifying the foundation of next-generation energy technologies. This shift not only brings sustainability benefits, but also drives the transition from resource dependence to energy independence, a major leap toward achieving clean and efficient energy goals. Technical issues like slower charging compared to refueling have already seen significant improvements, making EV charging more convenient. However, infrastructure development and technology costs still remain critical factors in making sodium-ion technology widely accessible to consumers. Forecasts suggest sodium-ion batteries could become mainstream within 2 to 3 years, even though lithium-ion remains the dominant choice for EVs at present. The Tesla Model 2, the $26,000 electric car Elon Musk has mentioned, remains one of Tesla's biggest mysteries. Although it's expected to be an affordable mass-market model, one of the most critical factors in achieving that price point is battery cost. While Tesla has already adopted LFP batteries for the more budget-friendly versions of the Model 3 and Model Y, there's still a significant gap to bridge before reaching the $26,000 target Musk set for the Model 2. In other words, LFP batteries are still not cheap enough to make the Model 2 viable at that price. As Tesla works to make EVs more accessible and reduce production costs, sodium-ion batteries are emerging as a compelling option thanks to three core advantages: low cost, good charging speeds, and high safety. Although it's unrealistic to expect them to outperform lithium-ion batteries, sodium-ion technology could still help budget-conscious customers experience owning a Tesla EV. And if the energy density challenge is solved in the near future, mass production of sodium-ion batteries at the Nevada factory may only be a matter of time. When weighing the pros and cons of sodium-ion and lithium-ion batteries, it's clear that each technology has its own strengths. Choosing the right battery depends on the specific application, cost considerations, and environmental impact. In this race, sodium-ion batteries stand out as a promising alternative due to their affordability, environmental friendliness, and high safety. However, lithium-ion batteries continue to dominate thanks to their superior energy density, well-established technology ecosystem, and continuous pace of innovation. In summary, the competition between these two battery technologies reflects the energy sector's dynamic shift toward more sustainable and efficient storage solutions. As technology continues to evolve, the coexistence of sodium-ion and lithium-ion batteries will provide more flexible approaches to meet the world's increasingly diverse energy needs. Okay, so if Tesla released a $26,000 EV with sodium-ion battery, would you be interested? Thanks for watching. If you enjoyed this video, don't forget to hit the like button and subscribe for more insights on electric cars and battery technology. Drop your answers to the questions in the comments. We love hearing your thoughts. One undeniable fact is that the Tesla Semi has always been the most questioned electric Class 8 semi-truck in the transportation industry. Yeah, it's been doubted even after proving its strength through real-world operations. Yeah, most people believe the Tesla Semi is a good truck, but they've always been skeptical about whether Tesla can mass-produce this Class 8 Semi. And the fact that the total number of semis produced so far can be counted on one hand has only proven the skepticism to be well-founded. From 2017 until now, nearly 8 years, very few people haven't asked the question, why hasn't such an efficient truck been produced in larger numbers? Now Elon Musk has finally given us an answer. The Tesla Semi has essentially been waiting for a new factory, along with major updates for the 2026 version of the Semi. Elon Musk revealed at a Tesla shareholder event that when you look at the old Semi and the new Semis hitting the road in 2026, you won't even recognize them as the same Tesla Semi. Okay, this version promises not only a dramatic redesign, but also a major turning point in manufacturing efficiency, as Tesla rolls out the Giga Semi production line. The new model will feature improved motors, better aerodynamics, reduced weight, and optimized production costs, allowing output to scale up to as many as 200 units per day. On top of that, the lower drag coefficient boosts energy efficiency, extends driving range, and delivers significant fuel savings. So the big question is, can the new Tesla Semi truly take down heavyweight competitors like Peterbilt and Volvo? Over the next 18 minutes, let's break down at least 8 major changes between the two versions. Over the past few years, the Tesla Semi has attracted major attention in the transportation industry thanks to its outstanding performance. Capable of traveling 500 miles even while hauling a gross weight of over 70,000 pounds, with extremely low energy consumption of just 1.7 kilowatt-hours per mile. To achieve this, one of the most critical factors behind its success has been the battery system. However, the battery is also at the top of the list of upgrades for the new version of the Semi. Okay, very few people know that for the versions produced from 2017 up to now, Tesla has been using LFP batteries for the Semi, a choice aimed at reducing production costs and improving safety for electric trucks. However, while LFP batteries offer several notable advantages, they also come with drawbacks that must be carefully considered over the long term. LFP batteries stand out for their excellent safety characteristics and stable operation in cold weather. This is a crucial factor for electric trucks, especially in cold climate regions where traditional batteries can suffer from reduced performance and accelerated degradation at low temperatures. LFP batteries have high thermal stability and are far less prone to fires or explosions, helping ensure operational safety, particularly for a large vehicle like the Tesla Semi. In addition, LFP batteries have lower production costs compared to other battery types such as NCA or NCM. However, the biggest downside of LFP batteries is their relatively low energy density. This means that to deliver a 500-mile range for the Tesla Semi, Tesla must use more individual cells in each battery pack. As a result, the 900 kilowatt-hour battery pack requires a higher cell count, which in turn increases the overall weight of the truck. Using more batteries also means higher production costs, even though LFP cells themselves are relatively inexpensive. The 2025 versions of the Tesla Semi face increased costs because they require a larger number of battery cells, making the battery pack heavier and negatively affecting the truck's overall weight and payload capacity. This issue is especially critical in the freight industry, where payload capacity and energy efficiency are make-or-break factors. The weight of the battery pack directly impacts the maximum load the Tesla Semi can carry, while also increasing energy consumption, reducing driving range, and overall operating efficiency. Although LFP batteries offer clear advantages in terms of safety and manufacturing cost, they are not an optimal long-term solution for the Tesla Semi, particularly as the truck moves into long-haul routes where efficiency must be maximized. With their lower energy density, LFP batteries limit the Semi's long-distance performance and add unnecessary weight. That's why Tesla has confirmed it will switch to HV batteries, also known as 4680 cells, for the new version of the Tesla Semi trucks. Okay, one of the biggest changes in the 2026 Tesla Semi is the adoption of the 4680 battery, the highest energy density battery Tesla currently has, with nearly double the energy density of LFP cells. The 4680 battery, which until now has been reserved primarily for the Cybertruck, is finally being integrated into the Tesla Semi. The goal of this upgrade is straightforward: to reduce the cost of the Semi without sacrificing performance. This means that with a higher energy density battery, Tesla can use fewer cells in each battery pack, while still achieving the same overall energy capacity. This also helps reduce the weight of the tractor. The 4680 battery features a tabless design, meaning it eliminates traditional connection tabs, which reduces energy loss and heat buildup during operation, ultimately improving efficiency and battery longevity. However, Dan Priestley has confirmed that the Semi's driving range will remain unchanged even with the new battery. The reason is that with higher energy density, Tesla can use a smaller battery pack instead of the current 900 kilowatt-hour pack. As a result, the Tesla Semi can maintain its 500-mile range while increasing payload capacity and offering a lower price compared to the previous version. This upgrade not only helps reduce costs for freight operators, but also strengthens the Tesla Semi's competitiveness against traditional diesel trucks. These improvements position the Tesla Semi not just as an electric truck, but as an optimized operational tool that delivers long-term economic benefits for transportation businesses. The 4680 battery now has a much lower production cost than in previous years, with Tesla successfully cutting battery manufacturing costs by up to 40%. At the same time, the 4680 battery offers greater reusability thanks to its longer lifespan and its ability to withstand harsh conditions with relatively stable performance, which is exactly why it's used in the Cybertruck. However, reports suggest that Tesla is not completely phasing out LFP batteries for the Tesla Semi. These batteries will still be used in the 300-mile short-range versions, helping to further reduce costs for shorter routes or regional freight operations. What's especially important here is that LFP batteries help lower the upfront purchase price of the truck. As a result, small businesses or customers who don't need long driving range can opt for this version to save on initial investment. While LFP batteries have lower energy density compared to the 4680 cells, they still meet key requirements for safety and durability. Another notable upgrade in the 2026 Tesla Semi is the new ultra-fast charging system. Tesla has improved its charging technology to reach power levels of up to 1.2 megawatts, significantly reducing charging time. Currently, the Tesla Semi takes about 40 minutes to charge from 10% to 70%, but the new version will need only around 30 minutes. This reduces delivery downtime and helps maximize operational profits for fleet operators. Now let's talk about the design changes. From our perspective, the Tesla Semi is still one of the most visually impressive electric trucks ever built, even though it debuted nearly a decade ago. Yeah, you could say its design was ahead of its time, and it remains the electric truck with the lowest drag coefficient to date. That said, Tesla is still making major revisions in the upcoming version, all in pursuit of one key goal. As you can see, the 2025 Tesla Semi features a fairly simple, rugged design with an upright stance and sharp angular lines. The cabin maintains a minimalist approach, focusing on functionality but not yet fully optimized. The large windshield provides excellent visibility for the driver, but its sharp angles make the overall design feel less fluid and aerodynamic. With the launch of the 2026 Tesla Semi, Tesla has carried out a design revolution, one that goes beyond aesthetics, to focus on aerodynamic optimization, reducing air resistance and improving energy efficiency. The front end has been completely redesigned, featuring smoother curves and far fewer rigid angles than before. This new design not only gives the truck a more modern look, but also lowers drag, improves energy efficiency, and extends driving range. In addition, the cabin has been reworked to be not only more attractive, but also more practical for drivers. The windshield has been replaced with a shorter, more easily removable unit, helping reduce weight and manufacturing costs while still maintaining excellent visibility. This change further enhances aerodynamic efficiency and eliminates unnecessary elements, all while preserving driver comfort. One of the most notable upgrades on the 2026 Tesla Semi is the addition of a modern LED light bar across the front, designed to improve illumination and strengthen brand recognition. While the headlights on the current version already make the front end look striking, we think many people will prefer these new updates. Overall, the new Semi definitely looks more distinctive, right? The slim, modern LED light bar not only enhances aesthetics, but also improves lighting performance. Which headlight design do you like better? Thanks to these changes, the drag coefficient of the new version has also been improved. By reducing drag to 0.33 from 0.36 on the previous model, Tesla has further optimized the design for greater energy efficiency. Although this may seem like a small change, in reality, a 0.03 reduction in drag coefficient can improve energy efficiency by 5 to 8%, helping the truck save energy and extend its driving range. One of the most notable upgrades on the 2026 Tesla Semi is the addition of a modern LED light bar across the front, designed to improve illumination and strengthen brand recognition. While the headlights on the current version already make the front end look striking, we think many people will prefer these new updates. Overall, the new Semi definitely looks more distinctive, right? The slim, modern LED light bar not only enhances aesthetics, but also improves lighting performance. Which headlight design do you like better? Thanks to these changes, the drag coefficient of the new version has also been improved. By reducing drag to 0.33 from 0.36 on the previous model, Tesla has further optimized the design for greater energy efficiency. Although this may seem like a small change, in reality, a 0.03 reduction in drag coefficient can improve energy efficiency by 5 to 8%, helping the truck save energy and extend its driving range. Most importantly, the 2026 Tesla Semi is also significantly lighter due to the use of lightweight yet durable materials. Reducing weight increases the truck's payload capacity while also extending range without compromising performance. The chassis has also been optimized to handle heavy loads while maintaining stability and safety during operation. Most importantly, the 2026 Tesla Semi is also significantly lighter due to the use of lightweight yet durable materials. Reducing weight increases the truck's payload capacity while also extending range without compromising performance. The chassis has also been optimized to handle heavy loads while maintaining stability and safety during operation. One of the most important factors in the 2026 Tesla Semi is the shift in manufacturing technology. With Tesla completing construction of the Giga Semi factory, the company can now produce up to 200 trucks per day, an impressive figure compared to the past, when production was limited and each vehicle was assembled almost by hand. This not only increases supply for the market, but also significantly reduces manufacturing costs, benefiting both Tesla and freight operators. Yeah, ultimately, all of the exterior changes Tesla has made to the 2026 Semi serve one single goal: achieving full autonomous driving. Driving a heavy-duty truck, especially on long-haul routes, is an extremely demanding job that requires constant focus and leads to significant fatigue. According to multiple studies, driver fatigue is one of the leading causes of accidents in the trucking industry, making it a major concern for long-haul drivers. Full self-driving doesn't just allow the truck to control itself over long distances, it also reduces the burden on drivers, enabling them to rest while the vehicle drives itself, particularly during long and stressful journeys. However, to make this possible, Tesla has had to significantly redesign the Semi's exterior to better accommodate sensors, cameras, and advanced driver assistance systems, optimizing the vehicle specifically for autonomous operation. As you see, Tesla has added a brand new camera location right above the front wheel arch, a pretty clear sign that the Semi is being optimized to become a fully autonomous heavy truck. And if FSD really makes it onto the Semi, this changes everything. The truck could operate almost 24/7, stopping only for 30 minutes at Megacharger. FSD requires an extremely precise and efficient system of sensors and cameras, so the vehicle can accurately perceive its surroundings and operate safely. To meet this requirement, Tesla has equipped the 2026 Semi with a new set of cameras and sensors. These systems enable the truck to detect objects, calculate distances, and adjust driving behavior, especially in complex situations such as heavy traffic, loading zones, or narrow lanes. With a production target of 50,000 units next year, Tesla isn't just aiming to solidify its position in the electric truck market, it's also setting a major milestone in the transition towards sustainable freight transportation. This production goal has the potential to reshape how logistics companies operate, while also creating significant opportunities for Tesla to further optimize manufacturing processes and reduce costs. Producing 50,000 Tesla Semis in 2026 is a major challenge for Tesla, but it also represents a critical turning point for the company. Previously, Tesla Semi production was extremely limited, with only around 300 units delivered to major customers such as PepsiCo, Walmart, and DHL by the end of 2024. However, with expanded production capacity and fully developed assembly lines, Tesla plans to reach this number next year, while also beginning to offer the Tesla Semi not only to large corporations, but to small and mid-sized businesses as well. This goal isn't just about volume, it's about quality and manufacturing efficiency. Tesla has made significant investments in building a fully automated production line at Giga, Nevada, where the Tesla Semi will be mass-produced. This approach reduces assembly time, optimizes costs, and accelerates production speed, helping Tesla reach its ambitious manufacturing targets more efficiently. One of the key factors enabling Tesla to reach its goal of producing 50,000 Semis in 2026 is Giga Semi, the company's dedicated factory for the new Tesla Semi. Tesla has made massive investments in this facility, which spans up to 4 million square feet and is equipped with some of the most advanced manufacturing technologies available today. By integrating on-site battery production, Tesla can reduce its reliance on external suppliers and ensure a more stable battery supply for truck manufacturing. Giga Semi doesn't just solve Tesla's production volume challenges, it also supports deep optimization of manufacturing processes, from chassis assembly to the integration of automated systems. One of Tesla's most ambitious goals is to drastically shorten the time required to build a single Semi, with estimates suggesting that one truck could be completed in as little as 10 minutes. This not only accelerates production, but also significantly lowers costs, opening the door for true mass production at a lower price point and making electric trucks more competitive with traditional diesel rigs. Although the Tesla Semi has traditionally been seen as a high-cost vehicle, the push toward large-scale production, combined with major updates planned for next year's version, will allow Tesla to further optimize costs and deliver greater value to customers. Expanding production scale helps Tesla reduce expenses related to raw materials, components, and manufacturing processes. As a result, the price of the Tesla Semi is expected to come down, making it accessible to a wider range of freight operators, including small and mid-sized businesses. In addition, mass production will further improve Tesla's operational efficiency. Highly automated factories reduce reliance on manual labor, streamline manufacturing processes, and save time, ultimately increasing productivity while lowering production costs. These advances in manufacturing technology allow Tesla to cut expenses and boost profitability, creating a strong competitive advantage over traditional truck manufacturers. The Tesla Semi has the potential to change the freight industry forever, thanks to the level of efficiency it delivers. So far, it's the only electric truck that has truly convinced us. Elon Musk once intended to manufacture this model in Europe to expand the market, but regulatory and infrastructure challenges have slowed that plan. Still, with the latest updates and adjustments, who knows, maybe we'll see the Tesla Semi operating in Europe sooner than expected. What do you think about the new version of the Semi? Do you think it can realistically operate in Europe? Let us know your thoughts and we'll continue to keep you updated. Thanks for watching.